Okay, the first question is how. Let's look at this. American Red Cross says that about 11% of the U.S. population is type B blood. Okay, so it looks like my probability of success is 0.11. And x, the random variable x, would be number of people who is type B blood. Okay. All right, the first one, how many blood donors should the American Red Cross expect to collect from until, that's an important word, right? It gets a donor with type B blood. So this is not it's not a binomial setup, it's a geometric setup, right? And the geometric mean was 1 over p. So 1 over 0.11, which is 9.1. And again, guys, expected value, you don't round up. Okay, so 9.1 is your answer. Don't round it unless it says rounded. Number 2, what is the probability that the 10th blood donor is the first donor? Again, it's another geometric setup. So basically, I want to know probability of having 10th person to be blood type B for the first time. So basically what it means is that you failed to find, you failed to find the blood type B for 9 people, right? Because you want to know the first person to be the 10th donor. So then the first person, first donor is the 10th person. So 9 plus 1 would make it 10. But you need to fail 9 times before you find the actual blood type B, which is 0.0385-ish. Okay? What is the probability that exactly 2 of the first 20? So this one is more like a binomial setup because you want to know the person being exactly 2 out of 20. So to find this, you use the combination, right? 20 choose 2, and then probability of success would be 11, 0.11, and then failure would be 18, right? Because 20 minus 2. Or you can use binom PDF for this one. So if you do binom PDF, you actually get 0.2822. So if you use binom PDF, remember the textbook said it's not enough to just write binom PDF and then write 20, 0.11, 2. You actually, sorry about that, need to explain what 20 is and what 0.11 is and what 2 is, okay? So you need to explain that to just write binom PDF. So I prefer you write it this way rather than just binom PDF. 4, what is the probability that at least 2 of the first 10 blood donors has type B? So at least 2, right? So at least 2 means that I want to know more than 2 people. So another way to look at this is 1 minus P of x being 0. I don't know why that line came. X equal 1. So I want to subtract these two, then I'll find that, right? So, or you can use binom CDF, obviously. And this one would be 20, 0, 0.11, 0, 0.89, 10. Oh, it wasn't 20, it was 10, right? 10 people. And then minus 10, 1, 0.111, 0.899. Okay, so this is the setup for this. And then the answer is 0.3028. Again, you can do 1 minus binom CDF. If I write it, 1 minus binom CDF, it would be 10, 0.11, 1, right? Because 1 is the last number I include. Next. The blood drive has a total of 150 donors. Assuming this is a typical number of donors for a school blood drive, what would be the mean and standard deviation of the number of donors who have type B blood? Okay, so to use that formula, NP and NPQ, you have to satisfy some conditions, right? So we need to check large sample, large number condition. Assumption. So this one would be where you do, is it a success and failure, right? Success and failure, NP is greater than or equal to 10. So N is 150, and then P is 0.11, and that is 16.5. So 16.5 is greater than 10, so check. And 1 minus P is greater than 10, so 150 times 0.89, which is 133.5. So this is also greater than 10, so check. So the assumption is met. Independence assumption is also need to be checked, because if I want to use the standard deviation formula, this one you need to check by 10% condition. So you can write a sentence like, it's safe to assume that there are more than 1,500 people, students, because it's a school drive, or donors, I guess, donors for the school drive, considering that this school is a large, like a school, okay, like not at women, basically not women. So then, since the two assumptions are met, we can use the formula, which is NP is this, right? The expected, the mean. So we already found that, which was 16.5, right? And then the standard deviation was NPQ, which is 3.83. So that's the answer for number 5. So number 6. Surprised by the low number of type B blood donors at the blood drive, the American Red Cross wonders if the 11% estimate was too high for your area. How many type B blood donors would it take to convince you that this estimate might be too high? Justify your answer. So this one, I think there are different approach. So the approach I'm going to take is normal approximation of the binomial. So we can use normal approximation because we satisfied the conditions, right? And then we're gonna assume that the donors were random, right? So it's a random independence and then large number, large sample, why don't I remember the title of the assumption? So then basically we can assume that the mean is 16.5 and then standard deviation is 3.83. So if it's normal, we can use empirical rules, right? And empirical rule says what? If you have 2 standard deviation away, then you have 90, I got this wrong last time too. 95%, right? So 95% of the population. So obviously, if it's going to be greater than that, then you know that it's kind of extreme, right? So you can even say like 3 standard deviation away too. But let's see what this cutoff limit is when it's a 2 standard deviation away. So then I'm going to do 16.5 plus 2 times 3.83, which is 24.5. 8.16 on this side, and then this side would be 8.84. So like it's asking how many type B blood donors would it take to convince you that this estimate might be too high, right? So if I have anywhere between 8.84 to 24.16, then yeah, I can be convinced that the 11% might be okay. So anywhere below 9-ish, I know the 9 is not exact, but like 9 is the closest number. So if I have a 9 or less donor showing type B out of 150 donors, then I would be convinced that this estimate might be too high. So even though this one doesn't look like it, it's kind of tying to the hypothesis test. Because remember that we reject the null hypothesis is something to do with p-value, wherever it's in this region, right? So even though it's not explicitly written as a hypothesis test, it's basically what it's going for. So 9 or less people, right? Then I'll be convinced that that it would be too high. Yeah. And because like 24 or more, then like 11% would be still like not correct, but it's not because it's too high, it will be estimated too low. That's why I'm looking for the 9, not this extreme. So we are looking at this and below. I hope that makes sense. I have more questions, but I'm going to stop this video here. So I guess it will be 4 parts, not 3 parts. And I'll come back with this question.